Hello everyone, welcome to the operating system series. Today we'll be doing the least recently used page replacement algorithm. In the last video we did the first in first out page replacement algorithm. So we need to replace the page if that page is not found in the frame. So this is another strategy in which we have to replace the page using this strategy called as least recently used. So how does this strategy works? So we replace the page which is not used for the longest time period if there is a page fault. So in case if there is a page fault, we will replace the page which has not been used for the longest period. Okay, so a page which is being recently used, even if it is old, if it is recently used, it is not replaced. Okay, the one which has been not used will be replaced. So in the coming animation we will use the frame of size 3 as we had recently used. So let us see the animation and then we see how many page faults we are getting for this example. So this is the animation for the least recently used algorithm, and we will use this particular reference string, the one which we had used in the previous example of FIFO. Okay, and the frame size also of 3. So first this is arranged. Okay, the first reference is 0, and since all the frames are empty, we of course will get first 3 page faults because that 0 is not there. So there is a page fault for 0. Then we need 1 is also not there, one more page fault. Okay, then next we require 2. Okay, so here star mark, this star, it represents there is a page fault, and absence of star mark means there is no page fault. So until now we got 2 page faults. Now we require 2. 0 and 1 are there, 2 is not there. Okay, so 2 is brought in and we get a page fault. Now next we require 3 is not there, and in this reference string we have 0, 1, 2, and 2 and 1 they had been recently used, and 0 was not been used for a long time if we compare this 0, 1 and 2. Okay, so 2 was recently used, and then 1 and then 0. Okay, so 0 is replaced. Okay, 0 is the victim. Okay, it is replaced by 3. Okay, so there is another page fault. Now we require 0 again. Okay, now in this when we want to get 0 into the frame, all the frames are occupied. So 3 was recently used, and then 2 and 1. Okay, so 1 will be replaced. Okay, so 1 is the victim. In this case we see 1 is the victim. Okay, so 1 is brought out. Okay, got out, and then there is one more page fault. Now we require 1 is not there. So we see that 0 was just recently used, then 3, then 2. So 2 is the victim in this case. Okay, so 2 is replaced by 1. There is one more page fault. Now we require 4. Okay, and if we see 1 and 0 were recent amongst 3, 0, 1 and 0 were recently used, so 3 was not used for some time. Okay, so 3 is the victim. Okay, so there is one more page fault. Now we require 0, and 0 is already there. Okay, so there won't be any page fault. Okay, then after this we require 1 is already there. Okay, so there is no page fault. Okay, now what happens next is we want 2. Okay, and 2 is not there in this particular frame, so 2 has to be, okay, something has to be replaced to make way for 2. So in this case we see 1 was recently used, 0 was also recently used, so 4 was not used for a long period as compared to 0, 1. So now 4 will replace by 2. Okay, although 0 is the oldest one, but 0 is not replaced, but 4 is replaced. Okay, so 4 is the victim. Okay, so we have 2. Okay, and then next, so this is the page fault. Okay, now we have to bring in 3. Okay, and we see that 2 was recently used. Okay, and 1 was also recently used, so 0 is the oldest one, that is not used for the long time. So now 0 becomes the victim. Okay, and it is replaced by 3. There is one more page fault, and then we have to bring in 4. Okay, and we see 2 and 3 had been recently used, so now 1 is the victim. Okay, so now 1 is the victim now in this case. Okay, and 1 is replaced by 4. So in all as we see, there are 10 page faults in this particular scheme. So this is how the least recently used algorithm works. So thanks for watching.